So right now we're discussing the ways after we have discussed how to find if the solution exists or not and so on. So right now we want to discuss ways to find the solution, and more specifically we will discuss some analytical ways to find some solution of the ODEs. First type of first method is separation of variables, and we're talking about finding the solution of linear ODE. So for linear ODE, we say it can be written as a function of the first derivative, function of y and function of x, which is equal to 0. This is kind of what is the first order ODE. And first order ODE can be written as in this form. Imagine if we can separate the variable and we separate the things in which we can write some function of x, some function of y times y prime is equal to some function of x. If we can write this the linear ODE in this term, things can be oversimplified very easily, because from here we can imagine that, okay, so we have this thing. Imagine just integrating both sides with respect to x. So this thing will become dy dx. So integrate this with respect to x, and we'll integrate that with respect to x. So since y is a function of x, we can write dy as dy dx times dx. So that's because y is a function of x. So a small change of y can be obtained as the derivative times delta x, or dx. So the left hand side of the integration can be simplified as g of y, and the whole thing we said that will be equal to dy is equal to integral of h of x dx. This is kind of the form the overall problem of separation of variables. So we will reduce it into two integration problem which can be found the solution of. Another an easy trick to remember this thing is from here you can write g of y, and instead of y prime you can write it as dy dx is equal to h of x, and then we can multiply both sides by dx, kinda multiplying, so dy is equal to h of x dx, and then integrate both sides. You end up with the same equation as above. So this is kind of the overall template for this thing. The first method and the second method is more of application than theory. So we don't have to understand the theory, or we don't have to understand the derivation that much, rather than just know how that there is actually a math behind it, and then we solve based on that. So we believe that for the first method we saw the math behind it, and we believe that there exists a math behind it. It's all about believing. So we get the first example. First examples tells we find the solution of dy dx equal to ex minus 1. The first question comes into mind, first technique. We have only 3 techniques. So first technique comes to your mind. Can we separate the x in one term and y in one term? And just write this thing. We can actually rewrite the right hand side as dx ex divided by ey. Try to multiply both sides by ey and ey. So ey dy divided by dx is equal to e to the x. So we actually separate y in one term and x in one term. After that, we can just integrate. So we go say dy times dy, ey times dy is equal to the integral of ex dx. The integral of ey dy is what? Is ey will equal to integral of ex dx is ex, and we just add one constant of integration, because if this one generate integration, every integration generates a random constant, but if this one generates a random constant and this one generate another random constant, we can combine them together and make an overall random constant, which is c. So in details, we can write this thing as ey plus c1, and this thing is ex plus c2, and then you can say let c2 minus c1 is equal to c. So we will end up into this thing. So if you want to find the value of y, you can say that it's the ln of ex plus c. So it's actually simple. So just try to see if we can separate the variables, put everything in x in one term, put everything in y in one term. If we can do that, then life is beautiful. It's easy to integrate, and it's just become problem of integration. The second example. So by this we found the solution to this ODE. A second example is y prime is equal to x times y cubed divided by square root of 1 plus x squared. So we think about our mind. Can we separate x to be in one side and y in another side? So we can write the first thing is dy times dx is equal to x y cubed by 1 plus x squared. Now another question that we may ask ourselves, which side should I put x and which side should I put y? Dy here, the top is dy. So you want everything here in terms of y, and to the left right hand side in terms of x. So the only thing that we have to do is by division by 1/3 is equal to x times square root of 1 plus x squared. We come and integrate both sides. So 1 over y cubed dy is equal to x divided by square root of 1 plus x squared. This thing is just normal power rule, which will be equal to negative 2 divided by y squared. Normal power rule. And this one will be dx. And this one will be substitution. And once if you think about it, by substitution, this thing would be 1 plus x squared, and we do the same thing as the previous one. We combine the c's together as c. Let me check this one. So this one, if we differentiate, it will become. So let me check the solution. So we can write as half 1 plus x squared, and differentiate the inside, become 2x, which gives you back into this thing. So this thing is actually a correct thing. And the last thing that you try to do is to separate y. So you can multiply both sides by y squared, and take the square root will give you two branches of solution. One of them is positive and the other one will be negative. Which means for some initial condition there may be two solutions which satisfy it. No, sorry, it doesn't mean that. It doesn't mean that, because yeah, for some solution it means that there can be two branches which satisfy it. For example, if you put as y equal to 0, then the positive side and the negative side can satisfy it. So we have two equations which satisfy, or two functions which satisfy one initial value problem. Therefore, the function is not unique. So this is the first example. So you can actually separate it from here. So y squared is equal to negative 2 divided by square root of 1 plus x squared plus c. And take the square root of this thing again, and just becomes square root of a really complicated thing. Let's see. And take the square root of that. Sorry. And also. And take the square root of that to find the solution of this thing. So this is the first method, which is kind of easy method. You just put everything that you have of x into one side, everything of y into another side, and just integrate it to find the solution. Another solution which can simplify the ODE is if we have another first order ODE, so y prime and y and x, f is equal to 0. If we can write it in the term of f of z prime and x is equal to 0. So if we have this kind of linear ODE, if we can somehow reduce it into the z prime and x, we call this type of